Hello friend, welcome to Data Lux. In this video, we are going to discuss a question from the machine learning. The question here says, consider the following six two-dimensional data points that is given here. From here we can say the value of x and y given respectively. Further, it says we apply the k-means clustering algorithm with k equal to 2. The initial centroid are chosen as the points 2, 1 and 2, 3. The algorithm is allowed to run for two iterations. So this is also we have to go for the only two iteration. After the second iteration, which of the following option correctly represent the updated centroid value of the two cluster, right? So now you are taking this point on the xy plane. So we can say here clearly this is the point x1, x2, x3, x4, x5. These are the point here, and we have to make two clusters. And as it is given k equal to 2, that means we have to go for two clusters. So this is the C1 cluster and this is the C2 cluster right here. And this point 2, 1, this is the 2, 1. So this is the centroid for B1, and this one 2, 3. This is the central value for the C2 cluster right here. So as we know in k-means clustering here, we applying here k-means technique algorithm. So it's a what it's a we have to find the distance of each point from this to central value. That means if we're taking this, let this is the x1. So we have to find this distance of x1 from these two centroid value, right? So if we calculate and for next we have to go for the all these points given here. And so if you see the table here for this, as we know, if we are finding the distance here, so apply the d of x comma y as a equilibrium distance, x2 minus x1 whole square plus y2 minus y1 y1 whole square. So this is the equilibrium distance when we apply here to find the distance of the value of these two distances. So now see the table here for the each point given here. So for the point x1, we have this is the 1, 1, and if we calculate the distance of x1 from this value b1, that is the 2, 1 from this point, so we will get the distance of 1 here. Similarly, if we calculate the distance of 1, 1 from this point 2, 3, so we'll get the distance of 2,24. And if we compare the minimum of these two, so minimum of 1, 2, 4 or 2.24, so this will get 1 here. So this minimum distance is 1. So we'll assign this value x1 to this v1. That means we assign, see here, so this is the minimum here of this with respect to this and this one. So we assign this x1 value to cluster c1 or with centroid v1 right here. Similarly, we will go for the x2 value, and if you see the here minimum, it is with itself. So this is the value 0 and 2. So minimum is 0. That means it will go with v1, and we'll go for the all, and we'll find the this assignment right here. So if we look here, x1, x2, and x4. So x1, x2, and x4. This value goes to b1. So b1 and b1 belong to c1 cluster, and that means here if you total number of point here in the c1, that is the 3. And similarly we'll check for the with respect to v2, and see here we have x3, x5, and 6, that is the with b2 assignment, and this is the with the c2 cluster, right? So in c1 and c2 we have 3 point is now if we calculate the mean value of mean value for this, or we can say the centroid value. So the centroid value of b1, it is updated value. So this is the 2.00 comma 1.33. So this is the for the updated value of b1. So this is the updated value here. So you can see here. So this is the for the B for the C1 cluster, and similarly we'll get the for C2 cluster updated value of B2. We'll get here 3.67 and 3.67 right here. So this is the for the B2. Next, next iteration, what you have to do? Again, iteration. Again, we have to find the uh, each point distance from this updated value. So let this is the x1 again, and we have to calculate the distance of this and this value right here. So if again we see we calculate the value of this. So now if you see this in the table here, so this is the we have to update this also. So 2.00 comma 1.33, and we have to find the distance of each value x1 uh, x1 x2 x3 from this central value, and similarly for this value v2 we have 3.67 3.67. So for we calculate the distance of each point from these two centroid value right here. And if you see this here, we have the minimum of these two, we have 1.05. So this is the minimum. So we'll assign this x1 to B1 cluster right here. Similarly, we go for the each point here, and we'll find the assignment value for the each cluster. So if you look here, the 4 point x1, x2, x3, and x4, this represent by the V1. That means this value will assign to V1, that is in the C1 cluster. And similarly, x5 and x6, this represent by the V2, and this will assign to C2. Now look again here. The cluster C1, here we have 4 point. So here we have C1 equal to 4 point, and C2 we have 2. That means this move value one point move in the another cluster, right? So this is the technique here. Now let's see the new updated value of B1. So this will give new centroid value for the B1. So B1 we have this is the 2.0 comma 0 and 1.75. And similarly for the B2 we have, so B2 we have the centroid value, this is the 4.00 comma 4.50 right here. So this is the for the so this is the for B2 of 4.4 comma 0 and 4.50 right, and this is the for the V1, so 2.0 and 1.75 right. So this is the case for the second iteration. Now in k-means clustering algorithm, this value always iterated and keep updated, and according to that we find the proper cluster. So as this value moves, we'll get a proper centroid value, and the other point move in this cluster, and similarly for the other cluster right here. So if you see the question here, so our question say, after second iteration, what is the value of the new centroid value? So this is the our A option is correct. That is the 2.0 comma 1.75 for the first for the C1 cluster, and this is the for the C2 cluster 4.00 comma 4.50 for the C2 cluster. So that's it from this video. If you find this video informative, please do like, share, and subscribe this channel. Thanks for watching.